So how do we create fractals? With a computer or on paper, what's the process for making these? It's always a three-step process. You pick the starting image or object. You have a wide variety of choices. Just pick something. And then you need to choose a rule for altering that object. And this is crucial. You have to follow that same rule infinitely many times. You have to iterate. Okay, there are infinitely many iterations for creating a fractal. So here's an example. I am going to choose a blue equilateral triangle. Bam. And then my rule is going to be every time I see a blue triangle, I'm going to cut out the center upside down triangle from it. Just like that. And I know that it might look to you like we're adding a black triangle, but I don't want you to think of it that way. I want you to think of like cutting paper with scissors and now there's going to be a hole in the center of this thing. So now here's the rub. We need to follow the rule infinitely many times, which means staring at this image, every time I see a blue triangle, and I see 3 of them, I need to cut out the center upside down triangle from it. And that means cutting 3 times, and I get this shape. If I were to follow my rule a 3rd time, every time I see a blue triangle, cut out the center upside down triangle from it, I'm actually going to be following my own rule 9 times and making 9 cuts with my scissors. I'm going to get that first fractal that I showed as an example, the Sierpinski triangle. Here's something cool that's going to be common with a lot of the fractal problems we're going to do. There's 1 triangle in the first stage, 3 triangles in the second stage, and 9 triangles in the third stage. And did you notice that pattern where like 1 triangle is always turning into 3? And then we have 3 different triangles turning into 3 triangles, so that's 3 times 3. Well, in the next stage, there's going to be 9 times 3, or 27. And in the stage after that, there's going to be 27 times 3, which is 81. So every time you are going to be multiplying by 3 to make the next stage of the fractal. Now here's an important conclusion from this. The full-on infinite complete fractal will have infinitely many triangles in it. Here's another example. We're going to start with a solid blue square. That's my starting object. The rule I'm going to follow is that every time I see a blue square, I'm going to delete it, and I'm going to replace it with 5 smaller squares in an X formation. So this is what I mean. Bam. So I've replaced the big square with 5 smaller squares. You can think of it, if you like, as like cutting out the little shapes on the sides, making 4 different cuts to make this like X pattern. Anyway, repeat forever. Repeating on this image means every time I see a blue square, delete it and replace it with 5 smaller squares. So you have to go to this upper left square and replace it with 5 smaller squares. And then you have to go to the next one and replace it with 5 smaller squares. And then the next, and then the next, and then the next. So this is the next stage of the fractal. We took 5 squares, and if you're counting, every square turns into 5 squares. So this pattern right here has 25 squares. What does it mean to do the process again? I have to take all 25 blue squares and replace them with 5 squares. And so this is what I get. This is 125 squares. That's 25 times 5. If I did it again, I have to take all 125 blue squares and replace them with 5 squares. And that's what I get. And then it keeps going and going and going. And so I was trying to walk through the math of how many blue squares there were in each stage. There's 1. 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625.